everybody. We're getting ready to do lesson 9.2 part 2 of grade 6 math today. And for 9.2 part 2 here, prime factorization, you got 38 points on your classwork sheet and 1 point on your into your notebook or notebook guide. Students, put your name, date, period here. Due date for onliners and homeschoolers. And today's bell work, teachers and students, is multiply these two numbers together. For 19 and 20, multiply these two numbers. Teachers, it's up to you whether you allow calculators or not. It'd be best if they did not use a calculator, but that's up to you. Give your students about 3-4 minutes. Okay, welcome back everybody for today's solutions to today's bell work. For number 19, 11.99 times 0.8 would be 9.592. And then 7.25 times 0.5 would be 3.625. Students, you should come up with that. And to today's first notebook entry here, explore activity 2. Using a ladder diagram. So a ladder diagram is another way to find the prime factorization of a ladder. So we started that a little bit in part 1. Use a ladder diagram to find the prime factorization of 132. So this will be a ladder diagram here, a little bit more formal than the tree, the factor tree. This is a ladder diagram here for 132. So write 132 in the top step of the ladder, which would be here, 132. And then choose a prime factor of 132 to write next to the step with 132. So what would be a prime factor of 132 to write next to the step? Choose 2. So we're going to put 2 here. So how many times does 2 go into 132 is the question. So divide 132 by 2. 2 will go into 132. 2 and write the quotient will be 66 in the next step of the ladder. So the right here would be 66. 2 times 66 would be 132. Now choose a prime factor of 66. So what would be a prime factor of 66? Write the prime factor next to the step with 66, which would be here. So what is a prime factor of 66? We're going to go with 2 again. 2 goes into 66 how many times? Divide 66 by that prime factor and write the quotient in the next step, which would be here. 2 times 33 would equal 66. Okay, the next step of the ladder. So we put 33 in the next step of the ladder. So we got this, here's our ladder here. Keep choosing prime factors, dividing and adding to the ladder until you get a quotient of 1. So what is a prime factor of 33 would be the next question. Would be 3. 3 goes into 33 11 times. And then a prime factor of 11 would be 1 and 11. So 11 times 1 would equal 11. So here is your ladder of factors here. And then here is your outside here would be your prime factors of what's on your ladder. What are the prime factors of 132 is the question. Here they are over here, 2, 2, 3, and 11. So how can you tell from the ladder diagram? Well, they're on the outside here. And also I got a yellow sketch around them as well. So you can tell that way as well. They're on the outside of the ladder. Here's your prime factors here. Okay, let's write the prime factor of 132 using exponents. So now that we have prime factors, it's possible that we can use exponents to put our factors in exponential form. So to do that, the prime factors are 2, 2, 3, and 11, 2, 2, 3, and 11. They are written to the left of the steps of the ladder. They're written out here. And they're got a yellow sketch around them. So 2 squared, we got 2 2's, right? So we can write this 2 squared times 3 times 11. So here would be writing the factors using exponents. Okay, we're going to reflect a little bit about what we've done. Reflect number 6. Complete a factor tree and a ladder diagram to find the prime factorization of 54. So to do that, how do we do that? And we're going to use a factor tree and a ladder diagram to find that. 7. Communicate mathematical ideas. If one person uses a ladder diagram and another uses a factor tree to write prime factorization, will they get the same result? And then explain that, students. Explain that. Teachers, give your students about 5 minutes for that one, or 3 minutes actually, and then explain. Okay, welcome back everybody. Yes, there's only one unique prime factorization. So will they get the same result? The answer is yes. There is only one unique prime factorization for every integer greater than 1. So whether you use a tree or a ladder, you're going to get the same result, whether you use a factor tree or a ladder diagram. And that is 9.2 part 2 of grade 6 math. And email me animatedpowerpointmathvideo at AOL.com for questions or course materials. Thank you very much.